Hello functions. Today we started with this warm-up. So I would like you to go ahead and hit pause, and I would like you to try this warm-up. This is based on the learning that we've done in the last couple days with new input. So please do that. Okay, so we are going to go through this pretty quickly. I want to do A, which is G minus F of 2. So the first thing I'm going to do is plug in that 2. I'm going to find G of 2, and then I'm going to subtract that from F of 2. So we are looking at these like two different functions, because that's what they are. So my G function, my new input is 2, so everywhere I see an X, I'm going to replace that with a 2. So I end up with 2 squared minus 9 minus, this comes from this right here, minus 2 times 2 squared plus 5 times 2 minus 3. Okay, so then I do the computations for that, so I get 4 minus 9 minus 8 plus 10 minus 3, which ends up being negative 5 minus 15, and I end up with negative 20. So hopefully you all got that. Let's go ahead and do B. Oops, for some reason my B, hold on. So there's the answer for B. You should get negative 14, so go ahead and hit pause and do B. Okay, so we're going to go through B. So the first thing I want to do is I'm going to get that new input of negative 1. So I'm going to find F of negative 1 and add that to G of negative 1. And that means everywhere I see those X's, I'm going to replace it with my new input. Because remember, F of X is just Y equals. So now I'm finding, like this says, what is the answer when my input is negative 1 in F, and my input in G is negative 1, and I add those together. So we're going to do that. So everywhere I saw an X, I replaced it with that negative 1. You should see that in the red. Then I went ahead and I did the computation. Now, a lot of people got this wrong because remember, the square belongs to everything inside that parentheses. So we want to be really careful that we get negative 1 times negative 1 is a positive 1. All right? So we get 2 minus 5 minus 3 plus 1 minus 9. So we get negative 6 minus 8, which is negative 14. And we knew that because we started with the answer. So let's go ahead and go into the last one. So we have F times G of 1. And again, I'm going to replace, I want to find out when my input in F is 1, what is that answer times when my input in G is 1, what is that answer? So that's what we're doing. So we're going to plug it all in. And we end up with 2 plus 5 minus 3 this time. So we end up with 4 times negative 8, which is negative 32. But I think my face is in your way, so I'll move it. Negative 32. All right, so if you have any questions on that, please come to class with those questions. I want to answer them. This is just the progressing level with operations with functions. All right, so one of the things that we've been having trouble with in our class is domain and range. So we're going to go through what we call parent functions. So go ahead and get your notes out. Make sure they're ready to go. We are going to be putting a lot of notes in. All right. Okay, so we are going to be talking about these these are called parent functions. Okay, so when we talk about parent functions, so the first one is a horizontal line. Now, for all of these graphs, there are arrows right here at the end of every function. I'm not going to draw them in and everything because it's kind of a pain. So just know that. So when we're talking about a constant function, something that could be, so this graph could be f of x is equal to 4. So what that means is for any constant, my domain is going to be going to the left forever and to the right forever in this constant function. So we're going to put negative infinity to infinity. But my range in a constant function is whatever my c is. So for this one would be c. And notice that I put it in brackets. I put it in brackets because we're using interval notation. I know that you guys know inequality notation, but we're putting it in interval notation, saying that the only possible y value in a constant function is that number. That's what we're saying then. So for this one, f of x is equal to 4, the range would be 4 in brackets. So when we look at this one, another way that we could see this, also when you put in your notes, make sure you put in the name. So this is a constant function. This is a linear function. Another way to see this linear function, you guys may be more familiar with this. F of x is equal to mx plus b. That could be any line, right? So then my domain for this function is it's going to the left forever, and it's going to the right forever. My range says that it's going to be going down forever, and it's going to go up forever. So the biggest thing that we want to make sure when we're talking about interval notation, our parentheses mean I'm going to never reach negative infinity. I'm never going to reach infinity. Or there's a hole there. So that is the domain and range for every linear function. So if I gave you something like f of x is equal, if I said f of x is equal to 3x plus 4, then you're going to say, oh, that's a linear function. I bet you the domain is negative infinity to infinity. So the sooner we can get to thinking about what does that parent graph look like, okay, if the parent graph is that, then I bet you then the new function is going to be that with some transformation. So we have the absolute value of x. Again, don't forget these have arrows. So we are going to say that this domain is going to go to the left forever and to the right forever. So from negative infinity to infinity. But the range is a little bit different on this one. And the range is, it is never going to go past this x-axis. So if we put anything in an absolute function, then we're never going to get a negative number, right? Because the absolute value is a distance, the distance from 0. So we are going to say that actually this is going to be a bracket because it can equal 0, but it's going to go to infinity, which is something it can equal. Now, when we talk about a quadratic, we're looking at this number right here, that exponent. If this number is even, then it's going to look similar to a quadratic. So when we look at this, our domain is going to be negative infinity to infinity, again with parentheses. My range, however, again is going to be 0 because I can't square a number that, even if it's a negative number, it's always going to be a positive number. So we're going to have a bracket because it's included, and it's going to go to infinity. So it's going to start at 0, it's never going to get smaller than 0, and then it's going to go up. So go ahead and hit pause and make sure you get this in your notes. So now we have some more parent functions. So here is the square root. So just in case you didn't know it, that means that there's a 2 if there's nothing there. So if we are talking about an even root, it's going to look something like this. One of the reasons, if we think about it, can we find the square root of a negative number? No. We talked about how that would be on the imaginary plane. It would not be on this XY axis. It's in a totally different place. So we are going to say that this is all real numbers. So then we have to say our domain is going to be, it can equal 0, but it will never be negative, and then it's got to go to infinity. And then my range is the same way. Since we can't ever have a negative number inside a square root, our answer is never going to be a negative number. So it's going to be 0 to infinity. And if we look at this, that's exactly what we see. That's an arrow, by the way. There. All right. So we have this cubic function. So now, just like with the quadratic, we're going to be looking at odd numbers, odd powers. But the domain is going to be negative infinity to infinity because it's going left forever and right forever. And the range, it's going down forever, so negative infinity to infinity. All right, this is a 3. Some students have had trouble seeing that. So now we're going to be talking about odd roots. So cubed root, 5th root, 7th root, 9th root. So odd, we're going to say that these are negative infinity to infinity, and the range is going to be negative infinity to infinity. Okay, so I'm going to hit pause. Go ahead. You do not need, let me see right here, do not need these words right here. We just refer to these as irrational, so don't worry about reciprocal or inverse. Go ahead and hit pause. I want you to think about what values of x won't work. So when we're looking at this graph, Notice that there's a space right here, like right here, and it looks like right here. So we're looking at this space. We have to consider that when we put that in our domain and range. So our domain, it is going left forever, so negative infinity, but it looks like right here it stops. It gets really close, but it's never going to get to 0. So it's going to get really close to 0. And that makes sense to me because 0 can never go in the denominator here. But that only takes care of this part of the graph. We got to talk about this part of the graph. So I'm going to use something called a union, so a U. It is a mathematical notation, that U. It's not a capital letter U. You'll see it in my math lab. You'll see it on the homework. You can use it. You'll see it as a U. All right, so now we got to talk about this part. So it looks like it gets really close to 0, and then it goes to infinity. So we're going to say 0 to infinity. Now notice that I don't have a bracket there, and that's because it can never equal 0. Now we're going to talk about the range. And the range, it looks like it gets really close to the x-axis, the range. So it does start at negative infinity again, so it's going down forever. But it looks like it stops right here and then jumps over here. So we're going to say that gets really close to 0. And, so we got to do that part. Now we got to do the top part of the graph. So then we're going to say it gets to 0, jumps, and then it goes up to there. So we're going to put to infinity. All right, so go ahead and hit pause and get that in your notes. All right, so now we're talking about this rational one. So this is when we take it to a power. So we've got this right here. It looks like a little space. So our domain is going to be negative infinity. Oops. So negative infinity to 0, union, and then we're going to jump and we're going to get really close to 0 again and go to infinity. The range is going to be 0 is the smallest to infinity. And that's all we have to do because there's only one top grade. So that's all. And then right here what we're going to do is look at this exponential. Another way that you may have seen this is f of x is equal to 2 to the x is something that was typical that we would see. And we're going to say the domain is still negative infinity to infinity. And the range, well, it's never going to go below 0. It's never going to equal 0. And it's going to go to infinity. So it's going to stay all up here. All right, so if you have any questions on that, please let me know. Otherwise, I'd like you to get this in your notes. And then there will be another video that has to do with some notation.